Hello everyone, in this video tutorial I'm going to show you how to model a masonry structure in ABAQUS software. So this is the example which we have a very simple structure, masonry structure. We used a very simple method without considering the mortar inside of the bricks, and finally after we completed the analysis, we will draw the pushover curve of this structure. So let's go to start. We go to pod. In the pod we have, let me show you the size of the structure we intend to model. We want a structure should have from this point distance. The structure size is 1 meter, length and 1 meter height. So 1 meter by 1 meter, and we also 1 meter, actually 1 meter 200 and 1 meter. And we also have a concrete beam is a lintel. We're applying a force here, compressive force or pressure, and then we're applying a pushover load in this point. So for modeling we have a full brick, so the brick size is 21, which means 20 centimeters, 10 centimeters. In case if you have I can go to edit, unlock. In case if you want to this is 100 by 100 and 200 that dip. In case if you want to simulate your own project, then you have to create your own brick, because the brick size is different based on the country and region. So one in office using 100 by 100, and this is full brick, off brick, and one RC frame. So the RC frame is unlock, and I can see 1 meter 120 that size. And the third part is foundation plate. You also can consider a concrete foundation, and also you can consider a foundation plate. If I use foundation plate, this is a discrete rigid element, which is a discrete element rigid. You can see shell planar, and it's discrete rigid. So it's discrete rigid because it's not required any divergence in the analysis, so automatically they will solve this problem faster, because the masonry structure is quite nonlinear structure, and we cannot easily simulate them if we consider the foundation as well and giving a very small meshes. Now the model is completed. We're gonna property. Mostly we have two material. One is for beam or lintel beam, and the second is for brick. And the brick is actually a brittle material, which we usually use Drucker material. We give you a density of the material here is 1.8 ton per cube millimeter, and we have given the Drucker 3 parameters. This is the angle of fraction and flow stress ratio, dilation angle. So these 3 parameters, these 2 parameters you can get from the ABAQUS documentation. for the Draugr proper hardening, you come here and you should conduct a compressive test, and you get the yield strength and absolute plastic strength of the material. Then you apply here, and that's done. Actually, I used one of the research data. I will put the link of that paper, you can use it, or I will give this INP file. You can use this material for your simulation. And this is the elastic modulus. And the last one is a concrete CDP material. Sorry, it's just a concrete with these properties, not giving any specific damage criteria. So we suppose that concrete should be sustained, not break or not do damage. Now we create more section. So we have two sections. One is concrete, one is brick. We asking brick, and we now for the discrete rigid, it's no need to assign material. So you can see there is no material. But if you come to the full brick, and you can see here is the brick material. After assigning material, you can go to assembly the model. Now you can bring all the assemblies. If I go to turn off this, let's if I go to turn off this, because it's already made, so this modeling is not too much difficult. Going to suppress, and also going to suppress as well this one with including all, suppress, and then I go to back to here, and I want to import. Now I can bring the first full brick, and I can bring the F plate. First I want to rotate which direction you want. I want to take this a Y direction, rotate in the Y direction like this, and then I want to take this one to rotate by this angle. Because so now again, and select this one here. So what I want to do is I want to take this point to here, here, or I can use this command, and then I can create list. First I want to shift this. This is 120 and this is 100, so 10 millimeter I want to push it in the Z direction. First I want to take this to here, and then I want to take again and just 0.0, and x is 0, y is 0, and minus 10 in the Z direction. So it's going to be, sorry, it should be, let me check the size of this. The size of this one is 160, 140. So I should get again this one, so 0, 0, and I should give 160, which is cost minus 300, 30 millimeter. Sorry, that was 0, 0, and then go to 0, 0, and minus 30. Now it's in the center. Now I can ask to populate this like this, but just in one just in y direction, in x direction. Now I can uh, populate it more in one direction, and then totally it's 1 meter, so we need about 5 bricks. 1 2 3 4 5. 1 2 3 4 5. Okay, now I can take and these 2 bricks, and I can put these 2 here. Now we created with the first one and the second one. We want to bring the off break as well. This is off, and I want to bring this one. Take this one and putting this to here, and now I want to upload one more full break. Let me first rotate this and like this, and taking this point to this point. Now what I want to do is just select these 2, and I want to populate, sorry, it shouldn't be, because now I want to populate just one, this one. Now I can remove this one, and instead I can populate, copy this one, just this one, and I can take it, copy, and I can take this point to bring to this point. Now it's finished. Now the next is I can select all this one and giving to the y direction, and this one should be 0, and I'm going to use this is 10, so this is 12 number. 1 2 3 4 5 6 7 8 9 10 11 12. Yeah, just one less. Now we created, and the last one we want to bring the RCP. I can rotate, by this angle, and then I move this to here. And now the model is completed. So like this you will finish the entire model. And the next we go to the step. So we don't need now, because this one, because we already created one, and you like this you will do the entire model. So previously I have created everything. I wanna show resume, and here are, and so this is it. And the next is going to create a step. In the step we want to define 2 steps, one for gravity loading and one for the lateral loading. So we go to the first, create, you can see edit, static, and I can select the nonlinear in the gravity, or even you don't need to assign, in case if you want, then giving a 0.1 and 100. And in the second is we want to conduct a time dynamic implicit. We can go to here and give 1 minute, and you can use any other option as well. So I use this first one, and giving in the 1000 I didn't reach all, so I'm giving 10,000. Later I can send you this model to you, you can finish. And I want to give 15, and this is minimum 1, and this is okay, and we're gonna say okay. In the step output, so we created 2 steps, and in case if you define for the concrete some damage you can add. And also I want to see some failure from the drag or broker material in this one. And here is the here is the time history record, and the first one is using a displacement which is called a set, and we want to create a set. Here first of all let me define a let me define a point reference point. Let me, yeah, here's called here. First I want to, sorry, it's a little bad. Okay, now we create the reference point. It's just easy, go there and create one reference point. Then in the step we want to create in the history request, just we want to ask to give us the displacement and the reaction force in this point. We also have another choice that we can get the reaction force in the bottom of the structure as well, but it's equal to this one. Now let's go to here and set displacement and just U3 and R3 and each increment of time. And then another one, we created one step for the base, and then you also can get from there as well. Interaction, here is the most important interaction. We want to create a multi-constraint point, so we want to constrain this point to the entire face of this reinforcement concrete column beam, because I want to push this here and the bottom is restrained together. You go to here called multi-constraint point, so like this. You can first select the point, control point, and then select this surface. And the last one, you also create this rigid body, and this rigid body should fix with this point, like this. And next is the contact properties of the mortar and also the brick. This is you have 3 choice you can do. One is this one, which is the simplest way. You're not considering the mortar, just considering the contact behavior. So the behavior between these contact is much more brittle behavior. During any external force, they will deform firstly in this mortar. So we want to create a contact, so the contact is we creating a tangential behavior and also normal behavior. You have choice to add cohesive behavior. Even you can create a one layer for mortar, and then contact two side of that layer, to bottom and top of this one. For the tangential behavior, I give friction, and the slip rate is 0, and also give some pressure contact. So other parameter is 0. This properties I got from that research paper. I will share with you. And normal behavior, just because the top and bottom is quite hard contact, two material is very hard, and you will consider it a hard contact too. And now then we go to here. You can create called all with self. So because the concrete is very close, if you one by one, if you create a contact, then it will be too much. Then you take all with self, is quite simple. And also you have another choice to create here, this one. If you want to find contact, so you here is a loss of contact. Now we go to the loading part, and we want to fix the bottom in that point, in the fixed that point in, and giving a displacement here. So the displacement I want 20 millimeter, which is almost about 2 centimeters. And giving for this one we can create a amplitude. Just we have the total time is 1 minute. We created one amplitude, so like this, which is applying step by step, 0.1, 0.2, and then 1. So this is the lateral load, and we want to apply before the lateral load we want to apply in the static step a pressure. So this is a pressure, and you can see this is 0.2 Newton per millimeter per square millimeter. So a very little force. This is not amplitude, just this is ramp. Now okay, and we finished. We can go to the meshing, and we create a mesh. So in this mesh is using 40 millimeter, so it's better make a small one. In case if I use fine mesh, then take so much time. The stem, brick, and beam, and fin plate. Now we can go to the job and create a job. So this job is actually already done, this one and this one. I want to, this was because I gave 1000 millimeter 1000 increment, so that caused about it because it's finished but the model is still trying to run. Here is the error, so it's called too many increment need, because I give 1000, so it's finished. Now I give 10,000. In case if 10,000 doesn't finish, you can give 20,000. Now I can go to create a job, and it's called dynamic 2. You also have a choice to increase the use polarization or using multiple pressure, then will take faster. Submit, and I go to submit. So this one is okay because in the first static we don't need this to get the output from the applying gravity load. Just we'll focus in here to see it will have any error, we will fix, otherwise it will complete. Here the first step is start the gravity load, and it will finish, but it take about 10 hours or 5 hours. Now here is the partial result we want to discuss here. So after so 0.1 in the second step dynamic, this is actually the performance of the behavior when it's pushed here, so that it will create a 45 degree cracking. So finally this showing the exact behavior of the such masonry wall. Now we also can see other parameters. Just I saw this one, the contact, the shear contact of between each element, and also the slip contact. You can see the stress. This is the stress concentration in this area, and then focusing in the middle. So you can check the linear elastic principles like this. Now we want to get the force displacement curve. So we go to create. In the time output we had this reaction REF2 U2, which we already defined. Now we're gonna save it, and here is the data. But this data is maybe a little weird for you. You think it's what will be there. But don't worry, because it's user dynamic, so it will have some noise. I'm going to operate here. I used a filter. This is filter. I'm giving the F2 should be filter using 1. I want to save it, RF. Now I can plot. You see, this is changed, curve is changed. Now next I want to combine. It's in negative. I use -1 times U2 U3, and again a comma -1 times REF2. And when I save, I can call push over curve. Push over curve. Now I can call it here plot. Other is no need, delete. Now you can go to check this one, and it will bring to you. So the structure is still in the yield part. In the yield part, this is I scaled about 50%. If I go to here, the common, I used 1, so this is very little. But after the analysis completed, you will see this curve will degrade, will come down. So you should wait until you reach that time. Now we go again, and we want to, just for visualization, we give 50. So this is the exact cracking region. Now this is the end of the tutorial. If you have any question, please put in the comment, and I will find time to answer you. See you next time.